Hello, today we are going to look at loans and mortgages. Now, loans and mortgages are installments or annuities type situations, but the way the information is given to us is different. So sometimes it's useful to use a particular formula on page 31 in our log tables if we are asked for the amount of money we have to pay for our installments. So how much money do we have to pay per month in order to pay off a loan or a mortgage? This is still a present value type problem. We have the present value of the mortgage or the loan, that would be P. So if you had a mortgage of 100,000 euro or 200,000 euro, that would be the present value of the mortgage. And A, as we said before, can often stand for our future payments for our payments on the loan or on the mortgage. So if we're asked for A, if we're asked for the payments that we are going to make on a monthly or a yearly or a weekly basis throughout the mortgage, then this formula on page 31 in our log tables can help make the question a little bit faster to do. But these are still present value problems. And it's important that we recognize that these are just present value problems, but because of the way the question is asked, it can be useful to just use this formula instead of doing our present value series, which I've written down here at the bottom of the page. Now, another caveat to using this formula is that they could throw in a curveball here where they ask you for the payments on the loan, but they tell you that the payments are made at the beginning of each time period, in which case you would have to go back and use the series method that we talked about before when we were dealing with pensions. So, with those caveats out of the way, if we're asked a straightforward question where they tell us that we have a loan or a mortgage for a particular amount and what would be the monthly payments or yearly payments, then we can use this formula without issue. If they tell us that we are going to make payments at the beginning of each time period, at the beginning of each year or each month, then we're going to have to use the series method, identical to how we dealt with pensions. And I'm actually going to do this question both ways to highlight that they are exactly the same method. This is, in point of fact, just a rearranged version of this series situation. So this is actually a derivation you can be required to do, that we have our series situation like we do normally, and you can rearrange the formula to get this here. So if we rearrange this version, we are going to end up with the exact same formula as we have up here. But let's dive into the question and see how we'd apply it in practice. Find the monthly repayments on a 100,000 euro loan or mortgage at an APR of 5% over 15 years. So we are looking at this situation. We recognize we're asked about monthly repayments, so we're going to write down our formula. A for our monthly payments is going to be P on I for our interest rate plus 1ti on t all over 1 plus I to the t minus 1. As with all of these things, you can see there's lots of brackets and powers going on. Be very careful to use brackets as much as you can when you're subbing into the calculator on these questions. Now let's write down the different pieces of information we've got to sub into our formula. A is what we're looking for. It's our monthly repayments. And it tells you that in the log tables, page 31. P is our present value. It'll call it the principal. And it's our 100,000. It's the value of the mortgage or the loan. I, we're given is I yearly, is 5%, which is 5 over 100, which is 0.05. Always go through those stages. And T is 15 years. Years is in 15 years. But I'm told that I'm going to be making monthly repayments. So this yearly interest rate and this time in years are both going to need to be converted to months because I'm asked about monthly repayments. So the time is fairly straightforward. 15 years, well, there are 12 months in a year, so it's 15 by 12. It's going to be 180 months. And my yearly interest rate, well, I know that my final value, must be the same whether I compound monthly or yearly. I monthly to the 12 must be the same. I must get the same final value from any payment if I had my yearly interest rate for 1 year. 1 year is the same as 12 months. Subbing in, so divide out your P's, your principals, because they don't matter in this case, it'll work out the same anyway. So I end up with I monthly, what I am looking for. 12 is equal to 1 plus my 0.05 to the power of 1. I get the 12th root of both sides. I end up with 1 plus I monthly is equal to, this ends up being quite a long mess of a thing, as so often happens, 1.004074124. And actually keeps going. When we subtract 1 from both sides, we end up with I monthly is equal to, it'll actually give you 4.074123788, we'll say, by 10 to the minus 3. Now 10 to the minus 3, you know that's going to mean that if we're going to end up with a smaller number, we can move our decimal place 3 places to keep it as a decimal, because this is even more of a nuisance to carry around than a decimal is. So it's going to be 0.00, so move the decimal place 3 places to make the number smaller because it's a negative power. 1, 2, 3, so we're going to have 2 zeros, and then 4.07412, and that just keeps on going. Now, it is not particularly nice to have to carry that around all of the time. So what we do in practice is we're just going to write it abbreviated on the page. Write it as 0.004 ... and we're going to keep this in our calculator. So this is going to be the answer on our calculator, so we could use the answer button on our calculator. So this is going to be, try and keep that as the answer on your calculator. The answer button on your calculators, so that you don't have to keep retyping in this very long decimal. So we talked about that before. Now, we have all of our different bits and pieces now for our formula. So let's sub into this formula here. A is equal to 100,000 on our IM. You can actually just write IM if you like. There's absolutely no problem with doing so. In fact, it can sometimes be better. 1 plus 0.004 ... Remember, the ... means I'm keeping this answer in my calculator. The power of 180 months, all divided by 1 plus 0.004 ... the power of 180 minus 1. All of that mess goes very carefully with loads of brackets into the calculator, and we get out 785.02 euro. Now, that's our monthly repayments on our 100,000 euro loan over 15 years at an APR of 5%. So a rather large payment to make each month. Now, the other way to do this is to use a series, and I'm going to write out the picture for our series and then come back to you. So we can construct this exactly the same way as we would have constructed our pension questions before, only this time we don't know our payments that we're making each day. Here I used the letter A. Here, for consistency with what I've done before, I'm going to use the letter F, but you can write in capital A if you prefer here. It's exactly the same meaning as our A in this version of the question. So what we do is write out, we know what our present value is, it's our 100,000 euros. So all of these payments, these future payments, add up to our present value of 100,000 euro. So what must all of our little installments be? And we can use our graph as our drawing as usual to keep track of our series. And we know that for these, we're always assuming, unless they tell us otherwise, that we are making our payments at the end of each period. So I've written out my series and only written in my first and last term. So now I recognize I have my geometric series. So I'm going to write in my geometric series formula. Now, when I have subbed in all of my different values, I see I have only one unknown. So I'm going to put all of this mess into the calculator. So you can effectively have the f outside, and this is 1 all over, or our 1.004, so on. Put all of that into the calculator, and we get 100,000 is equal to f on 127.385,158. Divide both sides, and we get f is equal to 785.02 euro. So again, just dividing both sides. So rearranging is we just divide by what the f is multiplied by, and this is going to be our monthly repayments. You can see that this is identical to what we get from the other formula. So in this specific instance, it's absolutely sensible to use this special formula, but it's important to recognize that it only works in this case where we are making payments at the end of the periods, like we would normally do for our pensions or our mortgages, our present value type problems, or where we know the present value of the overall payments would be the kind of link. And is there any other restriction to it? Yeah, this works more generally and links in better to other parts of what we do in terms of installment type work in financial maths. This can save you a minute or two in the exam, which is not for nothing. The only other thing to highlight to you again is the importance of keeping as many decimal places as possible, really keeping this iMonthly as a saved answer in your calculator, as in just keep it as the last thing you calculated, and you'd be putting in ANS anywhere that you have your interest rate going in when you'd be subbing this into the calculator. And it means that your answer remains accurate, because if you put in only, say, 4 decimal places here, when you're putting that to the power of 180, you end up with a significant error in your answer. And it can be easy to lose a little block of marks because you are out by enough that they can't give you full marks for the question. So it's important to keep as many decimal places in your interest in your interest rate as possible as you're going through the questions. That's why I have gone with these ... business. You're to keep that answer that you worked out in the earlier part of the question and sub it in using the saved answer, or the last thing you calculated button on your calculator, in order to ensure you get all of your decimal places and therefore don't end up with a significant a significant error in your answer. And those are the main things to keep track of. So anytime you get one of these questions, this longer method will always work. But if you recognize that you can use this formula, by all means open up page 31 and just use it. There's nothing wrong with using it. And that